Hello, one, two. Hello, hello.
Good morning to all respected officers here. I would first request our DDG and RMH2, Sri LMS Mora sir, to please come up on the dais. Sir, please come up on the dais, please, sir. I would now request our HOD, Sri Dr. Shaibal Ghosh Sahab, to please come up on the dais and take his seat, please. I would now request our Professor Saab, Dr. Pulakshan Gupta from Jadavpur University to please come up on the dais and take his seat, please. I will be during this. We all are his proteges, the product of the interest that he has shown in the subject, and through his teachings, we have also gained a lot of interest in the subject and learnings. Thank you so much, sir. We have a lot of fond memories in the 3 years that I spent there, and that's your generosity, sir. Thank you so much. I would now request PSS Madam, Jaya Chauhan ma'am, to please come up and present sapling to our esteemed guest, Sri Dr. Pulakshan Gupta Sahab. I would request Mona Lisa ma'am, HO, GSIWR, to please present a sapling to our HOD Sahab. And I would also request Priyanka madam to please come up and present a sapling to LMS Mora Sahab. Thank you so much, Jaya ma'am, Mona Lisa ma'am, and Priyanka ma'am. Friends, we have gathered here to listen to a talk on stability, formation, and destruction of minerals, some myths and facts. This is part of the online e-capsule course which RTD is conducting. It is titled Metamorphic Processes and Continental Evolution. We will be listening to 2 to 3 lectures in this series. This is the first lecture, and I am so glad that sir has accepted our invitation. He is not on a official visit. It is his personal visit, and therefore I'm so thankful to him for accepting our invitation, taking time out of his busy and personal time. So be among us, and like he has generated a lot of interest in geological subjects among us, it is time now that you also will gain a lot of interest and learnings from his teachings. Lastly, I would request our HOD Sahab to please present a shawl और सर का सम्मान किया जाए. Now I would give a brief introduction about sir, although I think it is not that necessary because he is such a well-known person. Dr. Sen Gupta serves as a senior professor in the Department of Geological Sciences at Jadavpur University, Kolkata, a prestigious center of advanced studies. Over a career spanning more than 3 decades, his pioneering research on grain-scale reaction mechanisms and ultra-high temperature regional metamorphism has fundamentally shaped our understanding of continental crustal evolution, particularly across the Eastern Ghat belts and the Precambrian terrains. His exceptional contributions to the earth sciences have earned him the highest accolades in the nation, including the prestigious Shanti Swarup Bhatnagar Award in 2006 and the National Mineral Award 2008 for his contribution in fundamental geosciences on the genesis of high-grade metamorphic rocks. His scientific leadership is recognized through elite fellowships across India's epic scientific bodies, holding the distinctions of Fellow of the Indian National Science Academy and Fellow of the Indian Academy of Sciences. Furthermore, he actively drives academic excellence and infrastructure development as the Fellow of the West Bengal Academy of Science and Technology. He is a recipient of the prestigious postdoctoral fellowship award. He also served as guest lecturer multiple times at the University of Bonn in Germany as part of the DART program. And beyond all his research credentials and global accolades, Professor Sengupta is equally celebrated at home. He is deeply cherished and well liked by generations of students. I am one of them, and who knows him not just as an advisor, but as a truly wonderful, inspiring, and approachable leader. I would also add one more thing. He has an exceptional sense of humor. That probably you will get to know through his lecture. And now I would request sir to please take up his presentation, and I would request Maura sir and HODs have to please take their seats. Yes, sir. It will be better. It will be better. Yeah. And as I know, you are literally mobile during your presentation, so you can use the space. Yeah. And HOD sir also made sure that I leave this space so that you can interact with all the students. Not students, officers.
Rohan, and what a surprise. I never saw you speaking so much in the class.
कहाँ से ये क्यों
This is my-
जगह नहीं है बैठने के लिए
Sir, I am not supposed to talk in class.
And
Then I would have called, I would have been known as a talkative boy.
no, outside. Outside. I mean, in Jadavpur, nobody can be more talkative than me. You know. So, anyway, good morning, everybody. I need not introduce myself. He has introduced more than what I know about me. So, that's it. And when I come to this type of gathering, I always feel I'm in the class. And this is the place
अम्बेडकर भवन में हो रहा है कहाँ पे है अम्बेडकर भवन हैं
actually, can you give me something so that I can release my hand? जेब में डाल दीजिए जेब में डाल दीजिए हेलो कॉलर लगेगा हेलो 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 Can you hear me, last bench? Can you hear me? No, they cannot hear. Hello? Last row, can you hear me? Great. So,
Are in the hall, please do not connect your mobile. Okay? Then it will create a disturbance.
okay. So you do one thing, you keep my mobile, otherwise there may be interference. Okay, so when Rohan sent me a mail that I have to give a talk, I came here as a photographer. This is my big passion nowadays, and which Rohan didn't mention, but that is how I am at the moment. Then a talk. Then I thought that what should I talk? Because this is a general gathering, and if I go into the depth of certain things, it may be reachable to someone and others will be left out. So that is what I never did in my life. in the class or in any lecture that if I reach only a small percentage of the audience, that's a failure of the speaker. So I did a trick. I made my PPT in such a way, this is more a general talk, and what I should say, that this is basically a perception of science from my heart. You please don't think that these are gospel truth. This is what I feel. Now, I made a little change. I have introduced the term hydrothermal system because the topic, it is my fault, the topic I sent is too general, that stability of minerals can form in many places. But once I fix it, then the talk will be more focused. And this fluid rock interaction, I begin. The fluid rock interaction, as you know, is the fundamental part to understand the evolution of Mother Earth, particularly the crust and mantle, and this is equally important for a number of minerals which are of economic importance, including the critical minerals. This term critical is little critical to me. To a scientist, every element, every mineral is critical. For us, there is no difference between silicon or gallium, same. No difference between nickel and magnesium. Then why this critical? The critical is from the viewpoint of the nation. Our prosperity depends on this. And please remember that today we may need 32 elements, tomorrow we may need 32 some other elements from the periodic table. So this is my urge to you, that take every element seriously. You may be in an exploration of, let's say, nickel or rare earth, but if you see that there is a potentiality of other elements, you must record. Otherwise what happens, after 5 years the nation will need those, and again you have to go through this exploration system. It not only is cost unfriendly, but this is an effort unfriendly as well, because you have to go in the same place again and again. But somehow in our country we don't have the concept of library of doing things. Whatever we know, we write it down, and then as and when it is required, we do it. So I start with this term hydrothermal. This is a common part. You know that many economic deposit and critical minerals, particularly the rare earth, are directly or indirectly related to this. The term hydrotherm is a little confusing to me. It has two words, hydro and therm. Therm you all know is temperature or heat. Hydro means H2O in liquid form. But surprisingly, in nature, H2O doesn't occur in liquid state in nature. It occurs in a special state whose property is between liquid and gas. In general term of science, this is called supercritical fluid. It moves faster than liquid but slower than the gas. Now, why? From the viewpoint of exploration geology. The exploration, basically what happens, nature has deposited something which have national interest, we just grab those material. This is the general philosophy. Now, if you want to deposit something, then first thing is you have to carry the precursor in the fluid. And then the fluid must find a way to go, and under suitable locales they will drop it. If you stop any of this process, the cycle will be cut. And that is the reason why you see that you get rare earth in this portion of a belt, but it is untraceable in other parts. It doesn't mean that the process didn't operate. There are things are very complex, but in a general way, I should say you don't lose heart. Possibly fluid couldn't go through that. Try to find the channels. If you want to have apple in your garden, you don't focus on apple. You focus on the land, you focus on the sapling, and then you water it. Once it becomes a big tree, then you get lot of apples. Exploration is just like that. If you say I go there and grab it, impossible. You have to see the total ambience. That is what I feel. Now, while making these things, I suddenly realized that I should tell or share my views with you. Since my student life, there is a barge phrase that you have to be innovative. And my teachers used to tell you have to be innovative. You have to think out of the box. You know, you must have heard in the different domains of life. But we are unaware of this thing unless we don't know what is box thinking. How do I know what is out of the box thinking? So that has been haunting me for a long time. So I thought that I should share my weird view on that. So I go to the pedagogic evolution of science. Please bear with me, this is not really geology, but that will tell us what is meant by box thinking and what is out of the box thinking. So I begin with these things. This is the cartoon everybody knows. The Newton is sitting beneath an apple tree and doing the equation, a force of gravity which is proportional to the mass and inversely proportional to the square of the distance. We all know. And this is a fundamental concept in science. This was done in that is a wrong thing. It should be 1687. I made it wrong. It's not 1987. Please, this is what always happens to me. So, now look at this part. It was published in 1687, but it was done in 1965-66 when entire London was, devastated by bubonic plague. What Newton couldn't do during his tenure in Cambridge, he did it when he ran to his, native place and sat over it just the way we did during coronavirus. He also did that, nothing to do, sitting and just watching here and there. Now, what is the significance? The significance is a quiet mind can only give you the innovative solutions. His tenure in Cambridge couldn't do that. All his great work, Newton is known by three major works. He has done a lot of things. He changed the paradigm of science, and three major works are calculus, optics, and the laws of motion. And all these three were completed when he was, in his native place, not in Cambridge. Then he came back and refined this thing, and that is his history. The impact of Newton is so much that for the next 250 years or more, whoever think about science, particularly physics, they believe that this is to be true. Our gravity method in exploration relies on this part. So it was continuing. This is what I call box thinking. Newton did it, I just follow it. It is just like following what we call SOP, the standard operating procedure. Whenever physicists or scientists used to write any equation, they considered this one as the gospel truth. So that formed the basis. Remember that for more than 230, maybe 250 years, till a patent clerk thought differently. This patent clerk is Albert Einstein. He was indeed a patent clerk and he had a lot of time. So he was thinking, why should I consider that Newton is right? Imagine what courage a person should have. Then he started thinking, and most of the cases from his mental experiment, if you just go through the way that Einstein reached to that level, you will find that he did mental, experiment. He was looking through the window and saw the clock is ticking, and several things came to his mind, so I will not elaborate that. And then he published these two revolutionary papers. Do you know what is his conclusion? That gravity is not a force. It's not a force. It's a space-time curvature. Obviously, there are huge resistance because out of the box thinking, our mind is not ready to accept. We always follow SOP. That this was there, so it should be here. And he faced lot of criticisms, including that this fellow has no idea about science and writing papers, and this was followed by, this is a Jew science which we should not be considering. But he remained unperturbed. This is what I feel is called out of the box thinking, not following the SOPs, and this is particularly required for mineral hunting. Whatever knowledge we have, there are two kinds of knowledge. One is what is already available in the world, but I don't know. I read or I take classes or attend lectures and gather it. That is one way of, one type of knowledge. The another type of knowledge is nobody knows, or what we know, my heart is saying it is not correct. What we call sixth sense. All of you have gone to the field, you know that sixth sense works better than your science. You have to smell, you have to feel that this is what should happen. If you go by the equations or all these things, well, these are important. I am not saying these are not important, but at the end of the day, this is our feeling, which we call gut feeling. Okay, so that is what the innovative thinking or out of the box thinking comes. I give you another example, that these two, conversation of these two I will come in a while. But this Newton and Einstein, whatever they did, the entire studies of them are called in a general way deterministic science. That is, if you ask a question about something, there should be a specific answer. If you ask what is the mass, somebody must say so and so grams or kilograms or something like that. If you say what is the time or how long we will be staying there, we expect that the answer should be in 1 hour, 2 hours, 3 hours or something like that. So these are called deterministic science. One great disadvantage of this deterministic science, it has become a fashion, and the reasons I will be telling. So this deterministic science is independent of the observer. It doesn't matter that whether I see or not, moon will be there. That is the basic idea of deterministic science, and that is precisely what Einstein told to Tagore. But Tagore didn't agree. It's not working? No. These four gentlemen also did not agree that science is deterministic, that you have 2 plus 2 equals to 4. No, it's not. And again, you know that these are the people who changed the paradigm of science, then developed a concept called quantum mechanics. Quantum mechanics sounds very nice, but people don't know that it tells that what you see may not be true. What you touch may not be true, or maybe one of the many options which are in superpositions. Absolutely weird situation. In exploration or in field work, many a time I realize that possibly this is the case. What we see or what we read may be one of the many possibilities. And these four gentlemen actually changed the concept of Rutherford about the atoms. That you have a hard shell inside and there are electrons moving around them. So long I was talking philosophy. And the trouble is, if you start on talking philosophy, some people will take interest, others will say, we all know. So I have to give you a real life example. That why this concept that what we see is one of the options, not the entire option. Well, before that, quickly tell you the conversation. Einstein, who was the victim. Hello. Einstein, who was the victim of this SOP following scientist, he became a person like that. Please believe me, this happened. He had a tremendous fight with Niels Bohr in mid-20s, in 1920 to 27. He never believed till his death that there can be observer's effect. He believed that whatever we cannot explain is because of our ignorance, not what we feel. And Tagore said just the reverse to him. Just you see, this proves the truth of the universe is human truth. That is what we see around us is created by human being, not by nature. There is nothing called absolute nature. And just have a look at Einstein didn't continue the discussion because he thought that Tagore is talking like Niels Bohr. So he stopped at that point. Now you see what is the statement of Erwin Schrödinger. It is the consciousness is fundamental and the father of quantum mechanics. Everything that we talk about, everything that we regard as existing, postulate consciousness. Exactly the same what Tagore said to Einstein. Just as a reference, don't take it as from the viewpoint of a religious belief. Indian script of Upanishad has this concept. Tagore was not a scientist, but he was a Vedantic. He discussed these things with Tagore on this point. Tagore didn't know there is a subject called quantum mechanics. Maybe he might have heard, but he didn't accomplish, any studies in quantum mechanics. But sometimes, I always tell my students, there is one truth. Roads may be different. Science is one of the roads, philosophy is another road. If it is true that all the roads should meet at one point. So, now from philosophy to real life thing, that is ACM, what we do every day. We are unaware that what we are doing are actually telling that what we see is not what is happening. You know the general thing. I will not get into the detail. We generate electron here. Most of the time we consider electron as particle, and this particles goes down, hit the samples, and you get SU secondary electrons if the collision is inelastic, and backscatter electron images. Life become beautiful with ACM. Pre-ACM age we passed through. We had to, strenuously watch the thin section. Most of the cases, thin section not well polished, and there are problems with the microscope. But once we have this picture, then it is amazing. So before I go into the mechanism of ACM, let me say a few things about this picture. This I have taken from a recent paper from our group. Now tell me, manganese is a critical element. If we are given the responsibility to hunt down the manganese, where do we go? Mostly sedimentary, metamorphosed sedimentary deposits. Because it is in our perception that in hydrothermal system, well, there are some few reports, but they don't develop, manganese deposit in a large scale. But this is what we got. This is braunite. Braunite nowadays is all braunite, but previously it was braunite with high silica and braunite 2, which is low silica. From the viewpoint of exploration, braunite 2 are more important because you have less silica or less gangue. I mean, the previous ore geology used the word gangue and the ores. So, this braunite 2 is very important. In this case, this part is braunite. What do you need? You don't need sedimentary, metamorphic or igneous part. You need silica, you need manganese. Okay, if these are made available, then it can form anywhere. In this case, the carbonatite didn't have any primary manganese deposits. None. But it had siderite. You know that siderite is a common phase in carbonatite, and many siderites have manganese in it. And it was, in our case, it was mangan 1 siderite, and the mole percent of MnCO3 reached up to 11%. and we needed a special scenario. Not every cases you have such a manganese deposit. There is a rock called jasperoid. This jasperoid is basically, this is very important for exploration. Many big deposits, sulfides, rare earth, and many other deposits are associated with jasperoid veins. Jasperoid is very difficult to explain. It has lot of silica, at the same time sulfides, oxide, manganese, iron oxides, chloride, and many other things. This is really very important. So whenever you study carbonatite, think of this jasperoid veins. Jasperoid veins also occur in other situations as well. Now what happened? This manganese siderite were decomposed by hydrothermal fluids and kicked out the carbonates, and since silica was already there, the braunite was formed. Now if you think that this is a carbonatite terrain, why should you go for manganese? Maybe big deposits are waiting to be explored. So please think about this, that if I need manganese, silicate or less silicate manganese, then all I need is manganese and silica. If they are available, it can form in any environment. Now you see that, well, it's ran away. This part, this bright part is pyrolusite. This is typical weathering, what the old people call supergene. So in many cases, this braunite is completely replaced with these things and making it a very good for extracting manganese. Pyrolusite is manganese oxide. Okay. So, you know, it's the mind of human being that creates the manganese deposits, not what we learn. In the textbook, you will never learn that braunite, pyrolusite, and hollandite can form with carbonatites. Okay, so from there, let me go back to these things, that what is the basic concept of quantum mechanics? This probabilistic science was challenged by what is known as classical Newtonian mechanics, because it's very difficult to handle. Because this is, it's weird in the sense that if somebody says, if the science says that what I am seeing may not be right, then you know, it's a kind of thing which our brain is not ready to accept. Now you see in ACM what happens. These electrons are coming out, fine, following the Newtonian mechanics, absolutely no issue, going through, hitting with the samples, absolutely, some are bounced back, following these things. But the story lies in between. So why do you use ACM? To magnify. Of course, we can get qualitative composition, but primary use is to magnify the things. Now you look at the equation of magnification. D minimum is the distance which can be resolvable. Smaller the d will be more magnified the image is. Okay? Because you can resolve the thing. Optically you cannot enlarge, then there will be an issue of pixels. Okay, you cannot see this. But the machine should get to a minimum value. Fine. Now look at this equation. We all know, but we didn't realize that this tube, this objective condenser lens, numerical aperture, I will not get into the detail of these things. These are constant for a setup. Consider. Then d becomes a function of lambda. Where is mass? Where is mass? No mass. Now you tell me that can you enlarge this board by hitting it with balls? Possible? Then we will say no. So how SEM is doing it? It's just like hitting balls, because electrons are tiny balls. So how it is possible? Either this is correct, then what I am seeing is not correct. At least this portion, this part is fine, but this portion, or something mysterious things happens, that the ball suddenly becomes wave and then again back to the balls. This is the best explanation. Let's see. This is the range of lambda or frequency we have. Our eyes see only a tiny part of it. We call visible spectra. Okay? And Newton gave the explanation of why we see these 7 colors, and he had 3 fundamental colors. Anyway, now de Broglie, an Italian Nobel laureate, he also thought over it. So if we can reduce the lambda, then D will be minimum. So how can I reduce the lambda? Because the minimum lambda we can approach is 400. So you have to reduce it to a very small value. Then he said he was energized, at least what I feel, by the work of Einstein, that light hits on a surface, eject electrons. So if the wave can be converted to a particle, why not particle to wave? And that is de Broglie's wavelength. So this de Broglie's wavelength is valid for moving electrons. At that time, that was the concept. So now look at that. What is the de Broglie's wavelength of electron when they are subjected to an electrical field with a potential difference, electrical potential difference. So now if you reduce from 400 to 0.243 nanometer, it can go even lower. Just imagine what D value will get. And that is precisely we need, so that we can see a shell within a chamber of a foraminifera very, very clearly, or the interspace of a clay deposits, what is there inside. Okay, it is all happening because of that. This is the standard equation. This is de Broglie's equation for electrons in the electrical fields. With a potential difference, it is dependent on V, that is the potential, accelerating voltage. And that is the reason why if you increase the voltage, it penetrates, not only penetrates deeper, you can enlarge the thing. Because lambda is directly, inversely related to V. So these are the things. Now, where do you have the wave? If we convert it to wave completely, following the de Broglie's equation, then we should not see these backscattered electrons or secondary electrons which are particles. At least that is how, well, this is also challenged by quantum mechanics, but I want to make life simple. Okay, so if this is the scenario, then where this conversion is happening, that it started off from the target as electron, it hits the surface and then the receptor receives the particle action, then where is the wave? The wave lies in the central part. I will come to this point, but before that I ask you a question, that these are beautiful colors, what is the explanation of colors? Why do you see a red color? From my student life, I am taught that color is a function of wavelength. So if the wavelength is larger, then this is red, and if it is towards 400 nanometer, it is violet and blue. So this is what? Then why do you see a red color or a blue color? Standard interpretation from our school days, we know that this white light hits on the object, it absorbs all the colors and release these things, and this goes to the eyes and we see the colors. This is the standard explanation of physics for a long time. Still now it is being used. The concept has been challenged by the neuroscientists. Now, if you consider neuroscience is a science, then you have to take their opinion seriously. Color has got nothing to do with physics. It is a creation of human brain. All the waves are electromagnetic waves, they don't have color or smell. So whatever color we feel is something which is created by our brain. That is precisely the concept of quantum mechanics or Tagore's view. That is the human being that is creating the reality. It is the human being who is telling this is blue, this is red. There is nothing red, nothing blue, nothing yellow. It's just the perception. Now, what it has got to do with exploration or field work? Our human brain is, you can read this. You can read this book. It's a wonderful book. It's a research book written for the non-neurologist. Even other doctors also read this. And it's very easy to think because neurology doesn't employ a lot of mathematics. Okay, they have surgery part and they have other part which we can understand. Surgery we don't need. Anyway, so this is the creation of the brain. Now, I give you an example. What is the color? Magenta. Can you see it? You see, if the physics was right, then it should have a wavelength. There is no wavelength which physics can explain magenta. Magenta has a wavelength between red and blue. It is the creation of the brain that you see, I see the magenta. So whenever you see magenta, you always remember that physics is not always correct. Human brain has got lot of things to do. Otherwise, we cannot see magenta. Fine. Now what we do these things in the field. Why this is necessary? Why this concept is necessary? That colors are the creation of brains. To the geologist or the natural scientist, human brain evolved in such a way, by the time a baby becomes 6 months, it can grab most of the colors. They can distinguish all the major colors which appear in the Newton's color wheel. All. Trouble starts the shades. For that you have to train the brain. If you don't train the brain about the different shades, the brain will not respond. I give you a real life example. This year in January we took a batch of students to Jabalpur. You all know that Jabalpur is famous for marble deposits, and there are different colors of marble. So one of the colors is golden marble. All the tourists know and they enjoy that. Beautiful. When light shines on this, it appears very beautiful. I noticed that the students cannot distinguish white and, well, this golden color means not the way we perceive. It's very light yellow type of color. I cannot explain, but I can feel, and you can go there and you can feel. Even the boatmen, they also know that what is golden yellow. The student came up with a map because they have to separate the things on the basis of this. This golden yellow is actually anchoritic marble. So the training was that you have to separate out the anchoritic marble from dolomitic marble. So obviously the color forms the important part. First days, none of the persons from any of the three batches could identify the boundary. So I thought that they didn't work properly because this is a tourist position. Next day I took them again. I said, place a boundary. Where is the boundary between white and golden yellow? None of them can tell. Initially, after seeing the first person, I thought he is colorblind. When I realized that none of the 46 students can identify these things, then I thought that, well, it is something different. Then I call a tea wala. I have been going there for many years. I know all these people. A person who sells tea. So I call him. So I gave a piece of rock to him, the golden yellow. I said, बताओ क्या है? वो बोला सर पत्थर है. वो तो जानता हूँ, लेकिन उसके बाद सर थोड़ा चमकीला है. Just see the description. It is highly recrystallized, so sun is falling on that, it appears this shining. So थोड़ा चमकीला है. और जो उसके आगे सर थोड़ा पीला लग रहा है. A complete silence among the students. Many students say, sir, we cannot see it. We cannot see it. Believe me. And then I realized that what is the problem? This Gen Z completely glued to the screens. They don't see the natural colors. So they didn't train their mind. You went there, you could identify, because at that time this screen business was not that much. But do you really think that it is so difficult to identify the golden in these things? And they didn't train their brain. So I had only one option. I said, this is a piece of white and this is a piece of golden yellow. Look at this for half an hour. Tomorrow you do these things. After one day, well, they showed some progress, but not completely. But they said that, sir, now we can understand what is the difference. Remember these things. Exploration is something what I perceive, you have to go and touch the material. Modeling doesn't help. It may be helpful to, frame your ways, but at the end of the day, you have to go and access either through machines or through hand, that you need a sample. If you do not know what is the color, if you cannot identify what is the color, then your map will be wrong and everything will be wrong. I tell you an anecdote. In 1991, I was visiting Kondapalli. This Kondapalli is a peculiar thing. Basic granulite and charnokites are interfingered. So there are some geologists working there. So first thing that person told me, sir, I cannot differentiate the color, sir. Because charnokite is greasy, mafic granulite is on the darker side. His eyes didn't notice the difference. Then I had to show him that you see these things, ये देखते रहिए, इसका कोई इलाज नहीं है, इसका कोई साइंस नहीं है. You have to train your eyes. What happened in 1991 also happened in 2026. So, there is no option, there is no alternative to going to the field. Sitting in a cozy chamber, you can never explore big things. Impossible, because color is created by human brain, not by science. So your machine cannot tell you what is the color. And the mapping is all about the boundaries. The boundaries, one of the major parameters of distinguishing two things is color. Of course, texture and other things play a role, but first time it is the color. Okay? So this is precisely the basis of quantum mechanics and the observation of the neurology. That you can rewire your brain. All of us can rewire. If you tell your brain, no, you have to identify, this is golden, this is golden, this is golden. Once it will rewire, next time immediately you will pick up. And that is the problem in petrography also. Same color, the first problem the student faced to distinguish a colored clinopyrex in an amphibole. So what science I can use to distinguish? You have to keep on seeing. I tell them, like all the teachers tell, that see, this is amphibole, this grain is amphibole, this grain is pyroxene. They look at, and then eventually they distinguish that this is amphibole and this is pyroxene. Every time you don't get ACM image. That is not possible. So you have to train our brain. Anyway, coming to these things, I come to this part. If I tell you that these are coming like this, hitting, and these are received, and I put a sensor here, just to observe how the electrons are flowing. I can do it because I am not stopping the flow. So if the science is deterministic, then nothing happens. What is the problem? But remember that there are sensors also, these coils. But coils doesn't try to access how the electron is moving, which in quantum mechanics called which way the electron is moving. If you put a sensor to track that how the electrons are moving, immediately it will collapse, you will not see any picture. You will not see any picture because it will behave like a particle. So electron in ACM behaves as a wave in the central part, starting particle, and when it interacts, then it again this wave is converted to particle, and the sensors, they sense, and if these sensors are like this, towards this, again this will collapse. And this was first observed in 1801. This famous double slit experiment, that if you keep on, firing photons, the lights, through two things, and with a detector here, then the diffraction pattern will be like this, just the particle behavior. That the particles which should go through this they hit the diffractor and produces an image. But if you take it out, detectors, and allow the same thing to happen, then you get an interference interfering bands, which is the characteristic of wave. Just remember the SOP is what? 1801 is long before the conception of quantum mechanics. It started with the famous work of Max Planck in 1900. So about 100 years. People knew this thing, but didn't take it seriously. Possibly quantum mechanics would have been discovered 100 years back. If you Again, I am harping on the same point. If you take science as religion, then it's a problem. Our problem is, at least what I understand, I am not going to generalize, but this is what I feel at the age of 63, that we treat science as religion and religion as science. We question why it should be like that, why Allah or God or Christ will be there, what is the science behind it? This is what we ask. But when we come to the science, no, this is Einstein's equation. This is Newton's equation. Now coming back to these things, as I said, that gravity depends, this gravity survey rests on this GMM by R square. So I was asking myself that, if this is the scenario, if it is not a force, then this equations has no meaning actually. Either Einstein is wrong or there is no meaning. So what did I do? I am not a physicist. So I discussed with many physicists. They said that, actually what happens, that in nature, the things around us, their size and velocity are so small that this equation works very nicely. So that is the rule of thumb. That is what we call rule of thumb. And what is the problem with that? The rule of thumb, and I said that, then why don't you use Einstein's equation? He has an equation for that. He said, no, it's very, very complex. This tensors equation is very difficult to handle. But for the normal system, it works very well. See, something which is not a force is being interpreted considering it as a force. But this is my absolutely weird views at this age. I can get a concession to have this weird thought. Don't follow me, but these are the things which come to my mind all the time in the last many years. I grow old, and I thought that I should share my view with this. Okay. So, how much time I have consumed? 1 hour. Then what will happen to the remaining part? Should I continue? Yes, huh? I spoke too much. I was so emotionally charged that I deviated from the main talk. Now let me quickly go through. This is the standard model of hydrothermal system. The rock gets cracked, fluid passes through that, it interacts with the wall rock, produces reaction zones, and the minerals are deposited, these things. I give you a real life example. This is that cracked field part, amphibole albite rich material, and then you have a contact zone, phenitized zone, and the outside part is granite. This is from Biramdi granite, Purulia. You will find it in many places, but that is not the issue. The thing is, these two, one is here, another one is here. Here comes the real problem. If you really want to understand the hydrothermal deposit, you need to understand how the fluid moves through these two bands, the fringe and the crack. Fluid flow through different mechanisms, and that's why you get different deposits. In this part, I start with this one. Basically, what happens? These are crack filling. That you see the fragmental textures and these things, and breccia and all these things. This is the deposits which you see, from Jabalpur, tremolite forming on the walls. Look at that. This was initially perpendicular, but because of deformation, it is just, slightly tilted. These are the examples of fluid flow in open spaces. That is the fracture field. And under microscope it is just like that. Look at that. Here it is this is what I mentioned as jasperite. That you have silica, you have siderite, you have apatite, then there are magnetized sulfide, etc., etc. Look at that. The grains are aligned perpendicular to the wall. This is the characteristic hallmarks that I am in the fracture zone, not in the interface. Now I come to this part. That is the fringe. Here the fluid flow or fluid dynamics completely different. Fluid doesn't flow through fractures. Well, there can be some little fractures here and there, but by and large they follow the grain boundaries, or even they flow through the defects of the crystals. Now you see how it looks like. This is a retrograde granular. You see the amphibole following the grain boundaries. This is not crack filling. This is a piece of things. You have ore deposits here and ore deposits here. These are gold and these are silver. Do you agree? Grain boundary process you know, very simple, that it is following the grain boundary. I identify one, apatite. Then I said that the colored one is gold and this one is silver. They look like this. Any layman would identify it like this. Do you call it gold? You call it chalcopyrite. Why you call it chalcopyrite? It is not gold. Forget about chalcopyrite. Why it is not gold? Because you have trained your eyes that gold has different shades, which you will not get here. This is pyrites and chalcopyrite. And this one is magnetite. It looks like silver to a common person. But to a geologist, at least you can say that, you may not say just looking at the picture that this is magnetite, but you can immediately tell that this cannot be silver as well, because I have seen silver. Your brain says that no, 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 no. Your science cannot help. Your brain will help. So this is the thing I want to harp on again and again. Then, well, this is another interesting part. This is from Shitampundi. This is the chromite and this is ruby. You know, Shitampundi anarthosite develops ruby. And this ruby is a very important economic deposits. And we describe the mechanism. I will not getting into the detail. My focus will be on chromite. Now, if you see it under microscope, unless your eyes are trained, you saw the bands, and these are chromite. What's the big thing in? So these are plagioclase, and there are small chromites here and there. Now, if you do the BSc image, then it becomes little serious. There are shades. This part is chromite and this part is aluminous chromite, and in some cases these are spinels. Now, when you go for chromite exploration, you may have a good deposit, but when you will send it to, for exploitation, then the metallurgy would say bakwas. The reason is the chromite deposits are actually economically calibrated in terms of Cr2O3 content. If part of it is kicked out, then its grade will be lowered. If you are not aware of these things, then what happens? You will identify the bands, do the calculations, and will say that we have so many tons of chromite. But actually you may get 30% of that. The reason is the fluid interacted with, and you see that this spinel retains the shape of the initial chromite. This process is known as pseudomorph. And how the pseudomorphs are formed? The fluid moves through grain boundary. In fact, this is solution and reprecipitation, molecule to molecule replacement. And part of the chromite which was kicked out was deposited as secondary chromite here. So all the gangs are not throwable. It may have this type of things. We did the calculations and we saw that part 40% of the chromium actually moved out of the rock. In textbook we read that chromium is a compatible element. Do you believe now that it is compatible? So no element is compatible or incompatible. There are compatible fluids and incompatible fluids. For this case, the fluid actually kicked out chromium. In most of the cases they don't. When the concept of this compatible and incompatible things came, then these processes were not there, very much there. So it was on the basis of partition coefficient. I quickly run through. Now, how the minerals are deposited from the fluid? We know that fluids are going through, but why it should deposit? So the standard interpretation is it interacts with the wall rock and it cools down and then it deposits. This is our general perception, that if any solvent is cooled, that its solubility decreases. But this is not the case for all, but bulk of the cases this thing happens. So this is in our imagination. Fine. The thing is, the moment we tell this, we presume that fluid is hotter than the rock. Otherwise, how can it cool down? Who gives us the guarantee that fluid will be hotter than the rock? So if it doesn't happen, then the entire concept falls down. Okay. So basically what we see or what we want nature to follow, nature will not follow us. Nature has its own law. Now what is that law? Again, this is not sacrosanct, but this is what we know. Now whether or not a material will be deposited or will be in the fluid will be dependent on their energy we call chemical potential. You need not go into the detail of this. This is a kind of energy. Okay. Basically, entire science is actually energy. The thing is that, let's say, I in the fluid, I want the I to be deposited, then it has an energy in the fluid and it also has an energy in the solid. Okay. And again it has two parts. Rock doesn't sense pressure, temperature and other things. Believe me, and you can read it. This is the basic part of thermodynamics. Rock doesn't sense any pressure, temperature or anything. It only feels the chemical potential. Now what happens? From these equations, you have two parts. One is the pressure temperature dependent part, another is composition dependent part. Its energy can be entirely changed by this compositional term or pressure temperature term or combination of two. This may be kept constant, but if you change it, its chemical potential will change. Now this energy is directly proportional to pressure. If you increase the pressure, its energy will be higher. If you increase the temperature, its energy will be lower. Now, after all this fight, if we see that chemical potential of I species in fluid is higher than the potential, the chemical potential of I in solid, immediately the fluid will drop. This is the reason why the hydrothermal deposits are formed, or any magmatic deposits are formed. If in any case, the fluid has lower chemical potential than the solid, it will never deposit. It may move through the rock, it will never get any deposits. So this is the fundamental part of mineral deposits in fluid system, be it hydrothermal or magmatic. So this is the last slide. This is my guru, spiritual guru, Erwin Schrödinger. Quantum mechanics is more spiritual than science. Richard Feynman, very good person, very witty person, and now he is no more. I am I am fascinated by his talk. So once he said that, how do I know that the equation, the Schrödinger equation or other equations what we are writing, and we expect these things to follow these things, particularly, whole world is now on quantum mechanics, not only ACM, the mobile you use, all the medical equipments you use, and this quantum tunneling and everything is primarily based on these things. It is not running by Newtonian mechanics, but still we love to do mathematics like this. So this Schrödinger, his basic idea was actually there is wave and one wave. The object is when the observer looks at the waves, then it becomes particle. And in his tombstone, he was a German, Austrian German. In his tombstone, that was in German, but I just translated it only this part. Just I read out, then you will understand what is science basically and what is out of the box thinking. That so all being is one and only being. Everything is one. And that continues to be when someone dies. Do you think this is science? Our perception is not like this. Very comforting. This tells you that he does not cease to be. This is not a spiritual statement. This is the fundamental part of quantum mechanics, that nothing dies. It's just the transition from object to wave. Schrödinger died in 1961. If you visit Austria, you must see his tombstone. The similar message you will get in Bhagavad Gita. Forget about the religious part. People who are separated by 3,000 years felt the same thing. This is actually, this quote is from Bhagavad Gita, but originally this was from Katha Upanishad. Okay? And finally, before I show you all, thank you, I must tell you, you just go through the life of Schrödinger. He has his autobiography called What is Life? And there he explained, if you don't have any idea in your mind, you cannot do mathematics or anything. It's very, very difficult. Because what you cannot imagine, how can you do something? The Schrodinger also had a problem, that he could feel that, well, the Newtonian mechanics may not be correct, or Rutherford's model may not be correct, but what could be the thing? The same thing happened to Kekulé, that at that time this, this closed bonds in organic substance was not there. So it was all aliphatic. The story goes like this: he was taking an midday dose, and then he dreamt that a snake is trying to bite its leg, his tail. So that is only possible if it is a ring-shaped thing. Otherwise, how can a snake try to bite his leg? And the story goes these things, that then he realized that who says that it will be straight aliphatic choice? There can be aromatic as well. I am very lucky that I had the opportunity to live in his place for 6 months. So it was really thrilling. I am not a biologist, I cannot value his work, but this is when I see that this person was there and he was thinking, okay. And Schrodinger has this problem, and somebody told him that this is the concept which are in Eastern philosophy. Now he is a German. At that time, German, British, they had this thing. So he went to Arthur Schopenhauer, the philosopher who translated that. He said that in 1 or 2 classes it will not happen. You cannot grasp it. And he regularly took the Vedantic class, not to be a Hindu, just to get that idea that mind is singular, energy is singular. And that is the thing. Manifestation can be different. Thank you very much. Right. So, if you don't ask me question, I will be asking question to you. So, deal is barabar. You have to ask question, and you can also take question from the online.
None, at least on YouTube I could see. WebEx. People who have joined on WebEx, please put up your questions.
So, any exploration or other type of research, you should not
Hello.
there and this is not there. Everything is possible. Nothing is impossible. I gave you a couple of examples. Nobody anticipates that manganese will form in carbonatite, and the chromite can degrade, even being chromite. So there are many such things. Yeah, yes, sir.
I'm really sorry, I'm following your question. Sir, actually, as you were talking about manganese, we have a lot of manganese occurrences in Nathdwara, Udaipur, and the Banswara area along fracture zones. And in this
Along fracture zones.
yes, sir. And these are hydrothermal manganese bodies. In my own work, I have recorded one in which we can find manganese veins within dolomite. And we have confirmed it with EPM.
And what type of minerals you get?
Sir, it is manganese oxide only. We have done the
Why do
XRD.
the size?
Yes.
Be very careful. It could be supergene type of deposits, because manganese oxide particularly is a tricky thing. Well, it occurs as nodules, FEMN nodules at the bottom of the ocean, but it is not like this. Actual scenario is oxygen bottom current, so you have to supply oxygen.
Yes, sir.
So in a vein, this is little different.
So we have that, and it is enriched with barium, and the signals, geochemical signals, are completely matching with the hydrothermal type. So that is why I said, sir, can manganese be related to MVT systems? Because in this area there are lot of MVT systems of lead and zinc, and we have also associated copper and silver with that.
Actually, I tell you, what I feel as a student of science. Don't try to correlate a person with his or her neighbors. Basic fundamental is chemical potential. They form independent. All the minerals form independent of each other. All. The correlation what we make is something statistical. That we found this thing associated with this like this. Just imagine that you have NBT, minerals associated. Let's say it's a well-known phenomena with manganese. Just take it from solid to fluid stage. So these elements are dispersed. Now they have to fall. Now everyone follows a particular rule, that its chemical potential in the fluid is higher than the chemical potential of that species in the solid. So only then it will deposit. It may so happen that other people also have the same thing. So you get all the minerals together. But there is no science, real hard science to explain that this will be associated with this. It depends on the fluid, that is what I said. It depends also on the fluid composition. Because chemical potential is an intrinsic property of matter. When it is solid, it is individual phase. But when it is in fluid, then it is the intrinsic property of the fluid. So X fluid here and Y fluid there will give you a completely different picture. So I personally don't find this very reasonable. Of course, human mind has different analysis, and that is true in most of the cases. This NBT will be associated with this thing. Just two things. First, if you want to hit a material, one, you have to get the source. I mean, the fluid must contain these things. The fluid may be there may be drop in potential of something, but there is no material. Then you will get no deposit. Another situation, the fluid was fertile, but the condition was not suitable. And the third point is very important, as I explained. The fluid was there, chemical potential was also low for solid, but the fluid couldn't pass through. In any of the cases, you will not get the deposit. So you focus on these things, that if you go for manganese, you go for the, well, there is, I shouldn't say that this may not be the right answer, that, you know, when they were in fluid, the chemical potential of manganese was certainly influenced by the concentration of NBT. That's true, and this is fact, and which may increase or decrease the chemical potential. Now, if you see that in 90% of the cases they are together, then you can go for this type of correlation. But remember that still you are left with 10%. Okay? Then you will miss. If you go by this logic that it was associated with this material in X place, that means in Y place if you get one, then others will fall in line. May or may not happen. Am I clear to you? Use your mind. Science is there.
Yeah, Rana, please.
Sir, I'm Rana Bandukotha, I'm geologist. Thank you for a very interesting lecture, sir. My question is, you talked about the formation of new minerals due to chemical potential difference from fluid to rock and deposition of it. Actually, is there any way to quantify it from any type of analysis, be it petrographic or APM analysis or SEM analysis? Because in field actually what the problem we face is, generally we get some kind of hydrothermal alteration, but the quantum of deposit, the quantity of deposit, that will make it qualifiable for economic one. So is there any chances that we can quantify the degree of hydrothermal alteration and the potential of that fluid to carry out that kind of material which may form economic deposits? Is there any way of it?
Great question. Principally, yes. but in practice it's a little difficult. Sit down, please. The thing is, whether it is qualifiable for economic deposit is something which the nation wants and our metallurgists want. Okay. What is not viable today will be viable tomorrow. It depends on the cost. For example, gold is extracted in the PPB level. We call it a, if it is in ppm level, it's a very good deposit of gold. But if you get niobium in ppm level, do you call it a things? No. What is the reason? There is a strong side. You cannot blame the metallurgist. The thing is, when they extract, what they do, what nature does, the nature forms a compound. There are seldom you will get free elements, graphite or something like that. Besides this, you get compound. Compound means you have bonds. Okay. And in a metallurgical process, you have to unbond the other thing. So when the bond is formed, then the material releases energy. Okay. So if you want to unbond, then you have to add that much of energy. And this energy is fuel dependent, and that is cost. Any element can be extracted from anything. Silicon can be extracted from quartz, but it is not extracted mainly from quartz. It is glauconite. Because silicon in glauconite structure has weak bonds. Okay, so you have to put minimum energy to break the bonds. Okay, and this is one aspect. But what you are asking, that how do I know that concentration wise it will be sufficient? Okay, and this is something extremely difficult, I tell you, because what was the material budget at the beginning is very difficult to predict. All you can do that, well, once you have this fluid track. I tell you again, one thing I forgot to mention, when you go for any mineral exploration which are related to hydrothermal fluid, the way we don't nurture the apples when we want to have them, so you have to nurture the tree. Here also you don't go for the material, you go for the fluid path, and that's why I spend so much of time. That you go for the hunt out for the fluid path. And once you know the fluid path, then you identify those zones, then you go for very specific part. Okay. So here then you can just move around or do some drilling. Otherwise there is no way that you do these things. Okay. No question is weird.
Put it closer. Hello, am I audible? Yes. So, sir, that may be a weird question because you talked a lot about quantum physics and all. And
Not a lot, it's just a general philosophy. I don't know it very well.
I just want to know what is the recent applications of quantum physics in geology. Like I have studied some of the quantum gravities are being applied to the gravity survey recently. And
Forget about quantum gravity, that is that I see part still now. Well, it's a very good thing. I tell you what is a quantum. I didn't mention because I was running short of time. Quantum comes from the term quantus, means how much. The quantity comes from there. Okay. Now, who are qualified for quantum mechanics? Theoretically, everything. Practically, the atom or subatomic. All the ions we are dealing with in hydrothermal fluids are quantum objects. All the elements which alter the mineral grains are quantum objects. All. In most of the cases, the geologists handle materials are quantum objects. Okay. That is the reason why there are infinite opportunities. What we see is one part of it. quantum gravity is something, because you know, whatever I have read, I am not a physicist, I mean, my knowledge is not formidable. The Einstein's relativity explains the big objects, how the big object behaves. Quantum mechanics deals with small objects, and quantum scale objects. And gravity is a funny thing. Okay. Now people are trying to address this thing through quantum gravity. And you know that there is a famous film called Theory of Everything that was on Stephen Hawking's life. So actually he made sincere effort. His principle was like this: if truth is one, the equation will be one. You cannot have one set of equations for large object, another set of equations for small object. So there should be one. And now it is converging towards that. If quantum theory can explain the gravity very well, then of course there will be one theory. Okay? But in geology, always remember that it's a very fantastic question, where most cases, particularly the deposits, when we think about deposits in the hydrothermal system, all the elements are quantum objects.
So can we apply the entanglement theory there? Because if I take a
I cannot tell you, I don't have much knowledge on this, but entanglement,
or is it only work in the quantum level?
I don't have much knowledge on this, but I can tell you that entanglement is a possibility. Entanglement is a possibility.
So which properties do we look for?
I cannot tell you, because this is a subject, you know, which, let me complete the Richard Feynman. I mentioned, but I didn't complete the sentence. And that is the answer to your question. That is Richard Feynman, his student said that, well, sir, we are doing these things, and how do I know that this is what the nature is following? How do I know that my equation is correct? Nature may be doing in his own way, and we are doing something in our way, and there is no way to verify that my way of thinking is actually followed by nature. Richard Feynman said, shut down, shut up and do the math. He gave a signal that this you can never do. You cannot.
Sir, we have two questions on WebEx.
Please.
One is from RMHNR. How the high-grade metamorphic terrains are important to search such type of minerals in Himalayan terrain?
High grade?
High-grade metamorphic terrains, how the high-grade metamorphic terrains are important to search such type of minerals. I think he is referring to hydrothermal systems in Himalayan terrains.
Well, Himalayan terrain is not different from other terrain. And you know that most of the orogenic belts, whose roots we are seeing at the moment, the Precambrian terrains, they once were like Himalaya. Okay, so if the materials can be found there, it can also be found there. On a serious note, you have to hunt for them. You identify the fluid path, particularly for hydrothermal, you identify the fluid path, and there is a rule of thumb to identify that. Not always you will be able to visualize these things. Sometimes what happens that you don't get abnormal minerals, like suddenly sulfide comes or suddenly oxide comes. You may not see this, but the best way to identify the conduits of fluid is suddenly you will see the grains are becoming larger and fewer. This is something which you can identify. Just follow the track, that where the grain size is larger than the others. So, I mean, in Himalayan terrain, the same thing applies. But remember that in fracture field, there is a different ball game. That is for grain boundary movement. For fracture filling, it's completely different ball game because the fracture releases the pressure. And many deposits, including quartz, they lose their solubility if you reduce the pressure. And that is the reason why you get quartz veins so frequently and in the fractures, because it releases the pressure and allowed it to precipitate. So temperature is not the factor. Again, pressure is not the issue. It changes the chemical potential, and that's why it is deposited. So identifying the fluid conduits is the key thing. Now what is there or not there, it is up to the nature. But if you know where to search, and these are the fingertips which is important. You cannot have a hydrothermal deposit without portioning the grains. Why nahi sakta? Why nahi sakta? It will flout the phase rules. Because system is open. The system is open means you will have fewer phases. And fewer phases means the phases has to be large. Because fluid is there, smaller grains will coagulate and form bigger grains. Or solution reprecipitate, you get bigger grains.
Thank you. We have one more question. This is from Prasenjit Burman. The question is, what evidences can be used in the field and in petrography to distinguish hydrothermal serpentinization from weathering?
First of all, Prasenjit, hello.
You can say hello. Yeah, there he is.
Okay. The question is hydrothermal and
From weathering.
actually serpentine doesn't form by true weathering. Well, there can be low temperature hydrotherm. It could be a mixed fluid, but serpentine is a mineral. A hydrous mineral is a chain silicate. You know that. Sorry, finders will sometimes most of the cases. This mineral have a stability, and that is unstable at the surface condition. Now you may ask that then why do you get it on the surface? It's just a kinetic failure. If you put it for years, then at some point of time there will be deposited. I am not aware of any serpentine deposit. Neither I am convinced that serpentine can form by true weathering. Just no fluid coming from below.
Sir, we have one more question on lyrics, please. This is a long question. What are the primary tectonic mechanisms and fluid sources responsible for generating the high CO2 fluids required to drive listenitization alteration in ultramafic rocks, and how to...
No, let me read out because it's a long... ultramafic rocks. थोड़ा ऊपर जाइए. Can you go up or just शुरू हो? What are the primary tectonic mechanism and fluid sources responsible for generating the high CO2 fluid? Leave it. Fluid required to drive alteration in ultramafic rocks. I see. Listivization in ultramafic rocks and how the structural pathways sustain such a high fluid rod ratio. Oh, this question is very, very good, but I don't think that I can satisfy you. My personal take on that, don't think about tectonic mechanism in this scenario. The tectonics is important to create the pathways. Obviously, because you need a fluid pathways. But remember one thing, again, this is something which we don't consider, that you don't need pressure or tectonic forces to make the conduits for fluids. Fluid can make its own pathways, and that is the reason why you see that a high grade rocks is retrograded, retaining all the features of the granulites, everything. It can make its own pathways. The principle is very simple. When the fluid interacts with the material and form a new material, it has a volume. If the volume of the product is smaller than the volume of the precursor, then obviously such reaction will create porosity and fluid will go through these things. And in another scenario, that volume of the altered material, which is the likely scenario, for example, pyroxene to amphibole, the volume, molar volume is increased, and in that case there are local fractures because the strain rate will increase, because it will push and the rock will resist, and because of these things it creates fractures and fluid flow through this. So don't bring tectonics unless you want your deposit as a fracture filled one. Then you may have something, but otherwise, tectonics is not the issue. Issue is the process. You can correlate with it. It may be valid in one place, but it may not be valid in other places. So that is your first part. And the source of CO2 is something very, very difficult. Something very, not difficult, nature did it, so CO2 was there. Now the CO2 can come from a number of ways, and there can be decarbonation of materials, and obviously the CO2, this orphan CO2 will certainly get into the liquid. But I have my own problem with these things, that if the fluid is rich in CO2, then one type of fluid movement will be stopped or at least strongly inhibited. That is, the grain boundary flow will be very, very difficult because of a phenomena called dihedral angle. For example, you have a small conduits like this. Okay, now if your molecules stretch like this, the fluid molecules stretch like this, then it will not fit through that. So in any case, you may have conduits, but fluid cannot flow. But in another situation, if the fluid molecules form this shape, that is low dihedral angle less than 30 degree, then it will very easily go through. The CO2 part, what I feel personally, that can only happen in the cracked region. And source of CO2, well, there can be two. One is already a carbonate to decarbonation, and which increase the CO2 partial pressure of that, and another one is related to carbonatite. And third part, which is very important, that fluid solubility and insolubility. You know, there is a phenomena called Henry's law, the way our heart functions, and that is the basis of all deep breathing. If you increase the pressure, solubility of gas in liquid will be high, be it oxygen, be it carbon dioxide. The moment you bring them to the lower crustal level, the pressure drops. The moment it drops, instantaneously the fluid moves out. And this CO2 can react with the wall rock and can form this deposit. This is the standard mechanism of carbonation of the ultramafic or many other rocks. The source can be anything, but the way it is deposited is because of that. And in my little experience in the field, I have seen that this is deposited in the fractures because this basically, releases the pressure and the fluid gushes out. Why do you do deep breathing? Why? Because the moment we do this, we generate a big pressure on the lung. And this lung generates these things in the blood. And the oxygen gets into the blood. Its solubility is more than, during the deep breath than the normal breathing. The same thing happens in nature. That if the fluid goes down, then, if you go in depth, then the fluid can dissolve lot of fluids. The liquid can dissolve lot of fluids. The moment they go up, they take out this thing. And that is the reason why the explosive volcanics occur. Explosive volcanics only occurs in the fluid-rich liquid. And the fluid creates its own fractures because this fluid fractures the rock. So, again and again I tell you, don't talk about tectonics because that's a secondary process. Think about the process. So, CO2 was there, CO2 evolved from the liquid or some other fluids and then reacted with the ultramafic, and if they are stable, then the carbonates will form. And what is, I think this is what. And any other question? When the transition from magmatic to hydrothermal. This is precisely we see right at this moment that the students whom I saw at the age of 18 now have become DDG. It's very difficult for me to track the transition, that when did it happen. and in nature. I'll invite the questions on mail so that we can answer it later. Yeah. Sure. So, this transition is very difficult to say because any fluid, any liquid, they releases CO2 because of the pressure factors. And if you concentrate on that, this is hydrothermal or aqueous fluid. I prefer the term aqueous fluid, and the rest part is liquid. And phenitization is the classical example. You have carbonatite, which is liquid, and phenitization is the fluid evolved from the carbonatite magma. And the deposits mainly forms in the main body. Phenitization, I am not saying it doesn't form, but in main bodies is maximum. The apatite deposits are there because you need big volume of material which cannot form, in a porous media flow. There are exceptions, but by and large, this is the rule of thumb.
Sir, I think we have to close it now because we have some more programs to be conducted here in this hall. So I would request all the questions which are unanswered as of now, they may please...
I will get back to you.
Yeah.
If you send it to me, I will get back to you.
Please send the questions in mail or WhatsApp so that we can reach out to sir with the questions and sir will be glad to answer them.
Absolutely. It's a pity that I overshot my talk, and that's why I couldn't receive.
No, if there was the second program was not there, maybe we could have taken the questions, but we have to cut it short now. And please, all of you,
I'm
please,
so sorry.
Have
a nice time. Have a nice time.
Please post your questions. The mail ID is dir.rti.wr@gsi.gov.in. Or I'll just send a text. Wait. একটা text করে দাও না। So thank you so much, sir. We
Thank
have
you,
a
it's a
lovely,
pleasure.
lovely session, and after a long
It's a
time, we were
pleasure.
talking to DDG sir as well. That this is so different from the usual presentations we have. Generally, we are discussing progress, numbers. This is a welcoming change for us, and
It's more philosophy.
no, sir, that is also included. But yeah, it felt like sitting in your classroom way back in 2000s when I was there in your class. And sir, we have a small memento for you. I would request our RMH2 sir, Sri LMS Mora sir, to please come up and present the token of love from GSIWR. This is the
you,
first.
sir.
Applause, gentlemen, ladies and gentlemen. We have
Thank
another
you so
one.
much, sir. It's a pleasure and an honor to come to this place and talk to the audience.
We have another one, sir. Sahib. And this is the special one. This is a sample of lead and zinc.
Oh, great. Great. Ah,
I think
Great.
sir will like this even more.
great. Thank you so much. अब आइए 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 चलिए सर Thank you. You just touch also. Thank you. Thank you.
Lovely. Thank you so much. Thank you so much.
हाँ बुझी थैंक यू भाई
I would
आप तो घूमते रहते थे हाँ बहुत बढ़िया सर हाँ तो आप तो घूमते रहते थे हाँ बहुत बढ़िया हाँ थैंक यू सो मच
Sir.
so all the members so thank you so much huh? Thank you so much beta thank you so much
Professor Shengupta,
hey.
Professor Shengupta, please have your seat, please, sir.
हाँ
Sir, बैठिए.
So you organize these things. Thank you so much. You are the main person. Otherwise, I mean, how could I talk? बढ़िया. आइए भाई.
Pulokda, বসে পড়ুন. Please have a seat. I had to speak in Bengali, otherwise I cannot stop him. Okay. On behalf of Western regions, today we are really extremely pleased to have you here. And personally, after long days, I have listened to a very fundamental lectures. It take me to my IIT days. I have also come across with some of the professors like him. One of them I still remember, Professor Supriyo Mohan Sengupta. He was just like him when he used to enter into the class. When he goes back, that time to PowerPoint slides nahi tha, blackboard tha. So it was a canvas. He used to draw a picture from the hill. The river is coming, and he is a master in clastic sedimentology.
Absolutely.
So he used to show, and when he goes back, then we reach to the delta and the estuarine regions. So it was a canvas. So today, what Professor Pulok Sengupta has delivered to all of us is nothing but like a canvas to all of you. And what basic and fundamental thing he tries to tell you, that do not just think the mechanical way the exploration. That is the most important thing. Just you think first, you see, and then try to emulate that what knowledge you already have. And that knowledge sometimes you have to relearn also what you have learned. Then you have to start, and then please, what I have understood, sir, that that exploration business, what we people are doing in GSI, it's highly mechanical. But it's
everywhere.
But it's not mechanical at all. It's very interesting.
No.
It's very interesting. The way
Extremely
you have shown
innovative.
that chromite slides and also the manganese one. So everybody, I was talking with my RMS2. He was telling, Soibal, वो chromite का तो हम लोग resource पूरा calculate करके दे देता. तो
वही तो बात है.
तो see, this is a basic fundamental. Is it a big science? No. You all know all these things. Only you have to apply it at the right moment. And I am really indebted on behalf of Western Region, sir, that you have actually given some very, very purest insights to our young officers. So I hope they will understand it, they will emulate it, and they will apply it in their next venture of work. They are fantastic officers. They are highly trained, highly educated, highly learned people, and I hope I have immense faith and trust on them. They will be able to do that. And thank you again, sir.
Thank you. It's a
To have you
pleasure.
here at Western
It's a pleasure. And field work is something still very close to my heart. And if you feel, and if I can make some time, if you think that I should visit the field and demonstrate what I have just discussed,
We will do.
I can tell you that why this thing. This is basically science lies in the brain, not in the equipment or in the equation.
Sir, we
Thank you.
will invite you again in the field. You have offered me a very good thing. We will take you in the field so that you can discuss more at length with our officers in the real problem area.
Real problem.
Thank you, sir.
Thank you so much. It's a big pleasure for me.
As we are very short on time, I will quickly propose a vote of thanks. I would first of all offer thanks to Pulak Sengupta sir for his insightful lecture, in which he has talked at length about many different things, from quantum mechanics to probabilistic science to deterministic science to fluid behavior, how it is dependent on chemical potential. Thank you so much, sir. It is like going back in my student life when I used to listen to your lectures. In the same line, I would like to thank our team at GSITI Hyderabad, Director Planning and Programming, Balaji sir, HOD Ravi sir, and here at WR, I would thank Mona Lisa ma'am, Jaya ma'am, the Director PSS, and HOD sir, who have been part of planning and executing. And this live streaming, we are doing it for the first time. This is the first lecture, sir, that we are going live on social media. So all the arrangements for making all the arrangements, I thank you, sir. I also thank my core faculty team at RTD WR. And lastly, I would thank all who have joined here physically and on WebEx and other social media platforms, especially to the people who have joined in Ambedkar Hall today. HOD sir and our DDG sir, State University DDG sir, both told me that you give instruction from our end that all of you have to attend. Lekin I knew that I don't have to instruct you. A request will do. Thank you for bringing in a full house. Thank you so much.
Thank you. Thank you. All the best.
And there is arrangement for snacks and tea at the back end of this hall. Before leaving, please, it's a self-service, so please have snacks and tea from before leaving. Thank you all. Thank you once again.
তুই তো ছিলি বেশ কিছুক্ষণ।
কোশ্চেন আনসার বলছি।
ও
আমি শুধু কোশ্চেন আর উত্তর বুঝেছি, আর কিছু বুঝিনি।
আরে এই তো হয়তো তো হবেই। আরে রোহন